Alrighty, let's get started. Good morning, everybody, and welcome to our Azure Red Hat OpenShift workshop. We're really excited to have you here today. My name is Ross Beard. I will be helping to support today's workshop with a lot of other speakers and supporting team members. Before we introduce ourselves, I do want to say a special thank you to our partners for supporting us on this event, Red Hat. We've been a Red Hat partner for 13 years, and they have been great at supporting us with these workshops to really focus on enabling our customers. Also, Microsoft, this Azure Red Hat OpenShift product is newish in the last few years, and it's an exciting managed service that we're excited to share a bit more about today. And then also Intel are supporting us on this event, so thank you, Intel. Introductions. I'm going to pass the mic to each of the team members here for a quick hello and a bit of a description about what they're going to be responsible for today. Derek, do you want to kick us off?
Sure. My name is Derek Sutherland, guys. Thank you all for joining today. I've been with Shadowsoft for 6 years. Prior to that, I worked for the Department of Defense doing cybersecurity software development. At Shadowsoft, I'm responsible for being a practice manager, which means I oversee technical consulting engagements. I participate in technical advisory over consultant practices, whether that be from advanced troubleshooting or architecture design and review. And I'm really responsible for ensuring customer success for the engagements that I oversee. My background and skills really lend themselves to a combination of software development, having 9 years of background there, to cybersecurity as it relates to software development, cloud automation, and then the actual implementation of automation and cloud technologies from a DevOps and SRE type practice.
I'm John Dingler. I'm also a practice manager here at my background is traditionally in the app dev integration space, specifically web services focused for many years, and most recently in the last handful of years on cloud technology across all the major platforms, Amazon, GCP, Azure, of course. And in addition to that, I've worked with various industries, retail, CPG, insurance, probably more that I'm missing, but I'll come from this conversation more from how do you use the tool from an app dev integration perspective, and then the nuances of the, obviously the cloud technology platforms.
Okay. Hello, everyone. I'm Tim Eck. I'll be your master of ceremonies today. I'll be driving most of the conversation and most of and pretty much all of the workshops. But John and Derek will be backing me up. I have a lot of great experience. I come from. At some point in your career, you just stop, and I've got 20 plus years in the industry. Everything from mainframe to business intelligence to big data. More recently, I've gotten certified in both Azure and AWS, done some cloud technologies, and I'm here to really kind of guide you through this process. We're going to do some hands-on, but I'd like to first just say thanks to everyone who's on. We're really looking forward to some interaction today, and love to get started here in a little bit.
Casey? You're on mute, Casey. All right, we'll skip you, Casey, and get to you at the end. Jimmy? You're also on mute.
Hi, sorry about that. Jimmy Hendricks here. I'm a customer success manager and product solution specialist here at Shadowsoft, so I'll be helping answer any questions you have throughout the the workshop today and helping facilitate those questions so our engineers if need be. Also, please feel free to reach out if you have any questions about Azure Red Hat OpenShift or OpenShift in general or any other Red Hat products within your organization or curiosity around that.
Mike.
Hey, I'm Mike Beaton. I'm from the North American channel team here at Red Hat. I guess just wanted to thank all you guys and girls for joining us today for this session on Azure and Red Hat OpenShift. You know, as OpenShift becomes the de facto standard for containerization of applications, you know, the ability to run it or port it across different environments becomes critically important. So, and you honestly couldn't be in better hands today with Shadowsoft. As Ross said, Shadowsoft has been one of our trusted Red Hat partners for over 13 years. Not only are they a Red Hat Premier partner, which is the top level partnership that we have with our channel partners, but they're also a Apex partner, which is this short list of incredibly strategic partners that we lean on for their deep expertise. In particular, with Shadowsoft's specialization on Kubernetes and OpenShift, they've really become one of our most important partners in our ecosystem. So again, you couldn't be in better hands for the next few hours. So I'm excited. It's going to get a little over my head pretty quick, but I'm excited for you guys for the next couple of hours. So just want to thank you for coming. And Bart, if you want to go.
Yeah, absolutely. Bart Zhang here. I'm also with Red Hat as a partner solutions architect supporting Shadowsoft, and I specialize in OpenShift as well as a number of key Red Hat technologies, and I'm here to support the workshop today just from a technical standpoint. So looking forward to everything we have to share today, and over to Shadowsoft.
Nick.
Nicholas Strauss-Matos with Red Hat. So I actually work as a technology evangelist, specifically with our partners. So that's partners like Shadowsoft and also Microsoft, helping to develop open source solutions on cloud service providers. So in this case, specifically Azure Red Hat OpenShift or OpenShift on Azure. So pleasure to meet everybody.
Thanks, Nick. And Cheryl will be popping on around 11:30 to say a few words. She's representing Microsoft and is really partnered with us on this initiative as well. Casey, is your mic working?
I don't know. Can you hear me now?
Yes, we can hear you.
Hi, I'm event coordinator here at the Shadowsoft. So I'll be helping you and Jimmy also will help out, hand out any login and password. If you have any questions, just please feel free to just ping us. Thanks.
Thanks, KC. And that brings us, before we do get into a little bit of an introduction and then passing it off to Tim to run the presentation, KC and Jimi Hendrix on our end are going to be working on getting you the specific logins for the labs. So over the next 15 or so minutes, they will be working with you via Zoom and chat. If you have any questions, obviously chat in the window there, but we'll try and get you set up while we go through some of this introduction stuff. All right, so a bit about Shadowsoft. We've spoken a bit about our partnership with Red Hat. We are the largest Red Hat partner in the Southeast. We really started really helping customers get enabled with Red Hat Enterprise Linux. And then over the years, we moved into JBoss application server, then Ansible with automation. And then in recent years, we've specifically focused on Kubernetes and OpenShift. As part of this transition, we've built up strong capabilities with these particular technologies, and we're in a great position to help companies adopt, implement, and then get enabled around this transformative technology so that they can successfully modernize their applications and development practices. What makes us different to some of the other partners, particularly the other big partners, is our focus on enablement and integration. We'll touch on that a lot today, given the focus on Azure and OpenShift. But we really strive to enable teams to adopt these new technologies. That means training, that means workshops like this, where we really focus on helping you learn how to use and manage these tools. And then from an integration standpoint, integrating with cloud providers like Azure, integrating with CI/CD tools, monitoring tools, security tools. That's really what makes us different. As a company, we have strong open source values. We really have been riding the open source wave, and we're big advocates for open source software. But we have a specific focus on bringing that open source software to the enterprise. We have a number of customers, specifically our sweet spot is some of the larger enterprise customers, given the need for an enterprise open source solution. Our capabilities, again, specifically focused on OpenShift, we're really are in a sweet spot helping customers with adoption and enablement of the platform. Secondly, integration with the different components, which I'll dig into in a little bit later. And thirdly, application modernization and migration. So we see OpenShift as the platform to enable application modernization, particularly some of the Java applications that may be a little harder to move to the cloud. We can help you get those applications cloud ready using Red Hat OpenShift. And from an integration standpoint, this is our integrated OpenShift framework, where as a company, customers told us over the last 2, 3, 4 years, what makes a successful implementation is when it's integrated with the other important parts of the business. And that means IT systems and the IT team. So yes, we can help with cluster configuration and basic implementation, but we really shine when it comes to integrating with cloud services, aka Azure, what we're going to talk about today. CI/CD pipelines, technologies like Jenkins. We have specialties in helping customers integrate. Monitoring, as you start moving more workloads to OpenShift, monitoring and that insight is going to be important. So we have relationships with technologies like Dynatrace to ensure that you have that visibility. And lastly, security. That's always an important factor in today's world, specifically relationships with technologies like HashiCorp Vault to manage secrets. So that's the quick introduction. Before I hand it off, actually, before we go into housekeeping, I did want to pass it over to Nicholas over at Red Hat. I asked Nicholas to say a few words today. He's been particularly helpful in putting together this ARO workshop and really evangelizing the ARO, which is the Azure Red Hat OpenShift product. Nicholas, do you want to say a couple of words before we hand it over to Nick? Before we hand it over to Tim?
Yeah, absolutely. And I'll keep it real short because I know people want to get to the meat and potatoes of this, right? Everybody wants to get their hands on and learning more, then start exploring the labs. But more than anything, obviously, Red Hat and Shadowsoft and Microsoft are here to really, make it Kubernetes, which is technically an open source project, an enterprise grade, solution that can be adopted and implemented in a variety of different ways. So you could consume it through Azure Red Hat OpenShift, which we'll talk about here, but there's also other ways of consuming OpenShift as well for Edge or Telco or AI and ML. So I would just really encourage everybody who's attending, if you have questions as we're going through a lot of this stuff, please provide feedback. Don't be afraid to reach out if you're looking for either documentation or if you have general questions. And no question in general is, too small or too large. So I'll leave it at that and turn it over to Tim. I know he has a bunch of great content to get into, but really happy to be participating. And again, if you have any questions, feel free to reach out.
Thanks, Nick. And housekeeping, just one last item. We'll send a short survey out towards the end of the workshop, and this feedback is really important so that we can improve these workshops in the future. Let's try and keep this interactive. Raise your hand using the Zoom functionality, come off mute to ask questions. We want to try and encourage that engagement. And we're here to enable you. So if you've got any questions, I've asked the Shadowsoft team and the Red Hat team to put Shadowsoft or Red Hat at the end of their names inside Zoom, so you can easily find us. If you have questions, feel free to ask them, and we'll have breaks throughout the day to keep us all energized, and Tim can go through that. So the intros are out of the way. Now down to the heart of the presentation. I'm going to hand it over to Tim Eck.
Okay, I'm gonna go ahead and come off of mute. Is everybody seeing the agenda for the workshop? Just want to make sure. Yeah, okay, good. So first of all, I want to say welcome again to the OpenShift workshop. We have a lot of interesting and exciting stuff to talk about today. A couple things up front I want to do is I want to go through the agenda, but I also want to kind of set some expectations. I know we have a lot of people online. I don't know everybody's experience with OpenShift, so we're going to start with really talking about the Red Hat OpenShift managed service, and we're going to talk also about some of the concepts around OpenShift. But what we want to do is kind of start from, the expectation we're kind of starting from zero, that some folks on here may not have a great deal of experience. So this is going to be maybe a little bit more introductory. So I'm going to move through the collateral, kind of the concepts fairly quickly, but we'll go ahead and stop if people have questions. And I know that, Derek's got some deep experience in here. John's got some experience from an app dev side with containers. So we'll, if we have questions, we'll go ahead and stop. As far as the actual lab goes, I'll do an overview to the workshop. There's a little bit of variation or deviation. I know we sent out an email about this from the way that the Aero workshops have been done before or other workshops have been done. Instead of having all the students or the attendees set up their own subscription or have to utilize their own subscription, Red Hat has set up a cluster for us. So we're going to have all the workshop users utilizing one cluster fundamentally. So I'll go through the differences. This is going to save us a little bit of time and get really to the meat of the agenda, which is how do I utilize OpenShift? How do I deploy applications on there? How do I scale the server for my applications? And talk also about CI/CD, so continuous integration, continuous deployment, the things that people really want to know, past the installation configuration. How do I really leverage this into what Ross said, those integrations that drive adoption, okay? With that being said, I want to do a little bit of word of caution. I have been through this multiple times. It is technology. Sometimes things don't work perfectly. And it's not to say there's anything wrong with the technology, but we're dealing with a lot of people in one environment. I've had issues. I was able to make it through all of the labs. And you may also have difficulty too, particularly if you're new to this. And we'll go at a pace that people can move along with us, but I'll probably hit somewhere in the middle of the pace where those who may be a little bit quicker or have more experience may be a little, done ahead, but we'll let those with a little bit less experience go ahead and have a chance to try to get caught up. And the way we've structured this is we've actually built into, and maybe I'll jump right into the agenda there. The first two sections for about an hour, we're going to talk about concepts. We're going to talk more about, containers and pods and services, and also the value of OpenShift to consumers. We'll start the lab setup somewhere around 10:15, 10:30, and once again, this is going to be driven by how quickly or how slowly we move. We'll have a break. And I put breaks at basically each one of the technical or the hands-on portions so that anybody who's a little bit behind or wants a little bit more time might have an opportunity to take some of that time to maybe wrap up. But our team is here to address any questions. So if you get stuck, I'll try to stop, or one of the other team members will jump in and try to help you. So after our lab setup, which is how we'll get everything set up so you can execute the commands, you can actually interact with the cluster. Then we'll go into the first lab, which is a microservices app, where we'll deploy that microservices app, and we'll also show the source to integration capabilities, where we're going to have, get updates going directly into a build into the microservices, or those microservices getting built into pods in the OpenShift cluster. Okay. Then we'll take a break for lunch, and afterwards we'll talk about the ARO internals. Then we'll also take a break after that, and then finish up the day with our CI/CD lab, which actually probably is a little bit faster than 45 minutes, but we're just going to allow enough time. And then we'll wrap up probably around 1:45 to 2 o'clock. So we'll have this as interactive as possible. We'll just have to pace it based upon the way people are, the way, everybody's moving along, and just the number of questions we get, or the difficulty or ease that which, workshop attendees are moving forward. Okay. KC has provided you, or will be providing you, a user ID and login to the portal, and also the portal information, so that you can actually access the OpenShift console in Azure. That's how we'll be accessing that. So once we get to the lab setup, that's where you'll be in order to start that process. And then we'll also do, for the lab setup, we're going to do the OpenShift CLI, where we're going to execute a lot of our commands from the OpenShift CLI to actually execute the labs. Okay, and I'll show you how to download that if you have not done that just yet. Okay, so we'll move quickly through some of the concepts here. So, why are we talking about OpenShift? And why are we talking about OpenShift on Azure as well? Containers are very exciting and transformative technology, but they do come with their own challenge, right? I mean, it is a cluster. It can, for a complicated microservices application, this can become a challenge, right? And so, a lot of, looking at the industry, Red Hat's talked to their clients, and what they've come up with is, what are the kind of concerns and challenges that clients are having with containers or a Kubernetes platform? So container security, right, is always a challenge, especially if you're in an industry where there is compliance issues. Security becomes a very paramount issue, right? And then getting to day two management. How do I install? How do I upgrade? How do I maintain my cluster? And then how do I integrate other existing enterprise technologies? And then application delivery. How am I taking my applications and being able to move those into the cluster, into OpenShift quickly and safely, right? We talk a lot about, being safe and fast, right? So I think a lot of the questions you need to ask yourself when you're evaluating these technologies is, where are you in the process? So do you feel comfortable, doing this yourself? Or do you feel like you have the experience with managing the cluster and all the complexities that might come around the cluster, specifically if you were doing it from open source? Or do you want to look at a platform that's already got those things built into, things like monitoring, things like security, or, an artifact repository already built in as capabilities, kind of get you up to speed quicker, right? So with Red Hat OpenShift, you get trusted enterprise Kubernetes, right? You get some of the best, security world-class support for handling that container security questions, right? You get a cloud-like experience everywhere. One of the advantages to the, OpenShift, and we'll talk a little bit more about the OpenShift ARO platform, is you get that same experience regardless of where you are. Different clouds, on-premise, and a lot of companies want that, where if I have a developer experience in one environment, I don't want to change and have different tooling, different sets, different processes in another environment, right? So you empower the developers to integrate without the technology getting in the way, right? So they can get to production quickly. First, the features out the door for companies that want to move quickly. And so you get really more out-of-box enterprise capabilities, far more than building it yourself, right? It's also built around developer productivity. So we have services and capabilities and tools throughout the entire life cycle, right? All the way from provisioning. We have consistent environments. We have tools where developers can do automated build and deployment, CI/CD pipelines, configuration management, and then also visibility into the platform with app logic and metrics, or app logs and metrics, right? So it really covers the whole gamut of different types of applications, multiple languages, databases, application services, microservices based for containers, and then also there is a capability to run functions within an OpenShift cluster as well. Okay. So the difference between what we've, a subscription-based installation of Red Hat OpenShift or something you would do on premise and using ARO as a joint engineered project between Microsoft and Red Hat is you get the enterprise-grade operations and you get the reliability of the cloud, right? The other thing is you get a service, a PaaS service, which is really different than deploying a cluster on your own, right? Some of those pieces are taken out of your hand. Some of the management pieces are taken out of your hand or responsibility, and they're handled by Microsoft and Red Hat, right? So you can build and deploy scales applications with confidence, and you can deploy very quickly. So, a lot of times we talk about this as, enabling getting up to speed quickly or leveraging, specifically companies who are looking at application modernization, who don't want to spend a lot of time with, the lower level detailed activities around setting up clusters, managing clusters, but really just want to enable, a kind of a fast pass to that application development, fast pass to the cloud. These are things that we want to do, right? So you can also scale auto scaling capabilities within the cloud, right? So any questions so far about Red Hat OpenShift Arrow on Azure?
I have a question, yeah. As you go through this, could you delineate a little bit between Azure and OpenShift? Because obviously OpenShift is its own thing and Azure has incredible capabilities.
Right.
And when you mention things like repositories and artifact repositories, stuff like that,
Yeah.
I mean, that's not intrinsically part of OpenShift, is it?
There is actually artifact repository capability within OpenShift, yes. And so that's one of the biggest differences is between, say, the different way of deploying a Kubernetes cluster is that a lot of the other solutions, you'll get the K8 deployment, but you won't get monitoring built in. You won't get an artifact repository that comes with it. I think the big delineation between obviously Azure is your cloud platform, right? It's going to provide IaaS or SaaS or PaaS services. The Red Hat OpenShift is actually a PaaS deployment of OpenShift onto Azure. So you get the benefits of a PaaS where the infrastructure layer, specifically the control plane and all the worker nodes and patching and management is actually part of the service that comes from Microsoft and Red Hat.
Right, I understand that. I'm sort of looking from the perspective of someone might be in a hybrid environment where they got some CI/CD being done by Jenkins or whatever build tools they have, et cetera, and then leveraging the cloud. And it's delineating between CI/CD being done by OpenShift, which is not really what we do in OpenShift, and this OpenShift is hosting your Jenkins builds or stuff like that. I'm just trying to delineate between the two so I can see.
Okay.
Tim, do you want me to take that?
Yeah, go ahead.
Yeah, so this is Derek. Okay, so a little background. I've been using OpenShift since OpenShift 2. We're now at OpenShift 4.5. Yep. So I've kind of watched as things have transitioned over time, and even before Kubernetes was part of it, I was using OpenShift. What I can tell you to answer your question a little bit more specifically is this. OpenShift offers integrations with Jenkins. What's built into OpenShift 4.5 is OpenShift pipelines, which is built on Tecton, as well as support for Jenkins. Now, when you're using ARO specifically, like Azure's OpenShift service, you can also use a more tight integration with Azure DevOps. So if someone was like, I'm in Azure, I want to use Azure DevOps, that's more than possible. You can use the integration that's pre-built there. What a lot of customers do in a hybrid environment, though, we're doing some things on premise with OpenShift and some things also in the cloud, is they'll use a Jenkins instance that then integrates to OpenShift in both environments. But then if you're using hybrid, there's a lot of other things you got to be considering, like going to a software layer for persistent storage solutions that are able to be migrated between both your cloud and your hybrid, on-premise stuff. There's just a lot of different details you have to be considering. But does that answer your question more specifically, or is there something else that you're considering?
No, it does. And I wanted to sort of keep that perspective as I go along, because, a lot of times in our technical roles, we can save a lot of money for the company by saying, look, you got all this expense going on here. We could leverage the cloud for that. Flip side of that is now you're married to the cloud. So, I mean, like investors, I always go in with the what's your exit strategy, which seems a little strange when you're adopting a new technology. But if you don't look at your exit strategy, you don't really understand what you're adopting.
And I think that's one of the biggest benefits of OpenShift, even if you're using ARO, right? And I think that ARO is an excellent solution for a lot of customers, even if you're in a hybrid environment, because it means that the stuff that's in Azure in this specific instance is you don't have to worry about the maintenance of how you're going to do updates to the cluster and things like that. Like that's all handled for you. And Tim will get a little bit into that architecturally later as he goes throughout the slides. But in regards to OpenShift in general as a platform, you have so many tools pre-built in that if you were to just use Kubernetes, let's just say, for example, raw Kubernetes or something else like an AKS, right? You would have to, in order to solve for, say, service meshing or metric monitoring or log aggregation, you would have to use the other cloud services that surround those tool stacks to get even maybe to 80% of what OpenShift gives you. In the case of OpenShift, all those things are pre-baked in. So even if you go to a different cloud provider, not only is the cost baked in for the usage of all those solutions rather than paying on a consumption basis in a cloud, you know what you're getting regardless of where you go. You have the same tool set everywhere. So you're not really baked in.
But that's my passion for OpenShift. You know, you're not tied to Route 53 or whatever it is because you're on AWS. You want to go to here. You know, your management's done within the OpenShift layer. And so that does give you, you know, with all due respect to Microsoft and the folks on the call, it gives you that independence to choose best in class.
Sure.
Exactly.
And with that, I'll give it back to Tim.
Awesome. Yeah, great conversation, guys. So I'll move through some of the features really quick, and I kind of really want to focus in on the fully managed clusters because that's really the big difference between, say, taking Azure and doing an IaaS implementation and laying down the cluster myself. Is that you get that fully managed cluster, right? The master infrastructure and application nodes, they're all managed by Microsoft and Red Hat. And then you're just really dealing with interacting with the cluster with your CI/CD pipelines, with your development tools, deploying your applications, right? You can integrate your own virtual network. You have HA. You also get that first-party Azure service. So clusters are deployed into your subscription, and they're included in your Azure bill, right? So you're paying a PaaS. You're working on a PaaS model, right? All of the persistent storage volumes are SSDs on demand. You're using Azure Disk, but the key here is the platform is managed and owned and patched and kept up to date by Microsoft and Red Hat in joint. So you get a true PaaS experience in this scenario. So if you have an environment where you're really application driven, application focused, and you're not wanting to spend a lot of time understanding how to install and manage clusters, this is a great solution for you, right? Okay, so really the next two slides are here to visually see that difference between maybe an IaaS type approach to even in Azure to deploying your cluster. You have all your components, your Active Directory, Key Vault, you have the API administration console, DNS, your IPs, your load balancers, your VMs, and then you have to split everything out into your nodes, right? With a ARO implementation, what you have is you actually have you manage all those components kind of below the line here, I guess you would say, in the blue box you see. All those pieces are managed for you. So you are responsible for user management, quota, your application lifecycle, and that is integrating your CI/CD pipeline. For our example, we have Jenkins actually is going to drive some of our CI/CD integration. It's running in a pod that's going to deploy applications to our cluster. And the rest of the part is managed by cluster creation all the way through support is a managed service, right? So, I mean, that's the way to think about it is, and I mean, even the gentleman, Nigel, who wrote the Kubernetes book, talked about if you don't really want, if you're not excited about managing clusters, you need to look at this as a PaaS SaaS service is probably the way for you to go. Right?
And Tim, I'd just add one more thing to that real quick. Specifically when you're looking at something like ARO versus like a vanilla Kubernetes offerings or something that just specifically offers Kubernetes as a standalone piece or component. Aero differentiates itself in a sense where it's more of a white glove type of service. And what I mean by that specifically is it's actively managing the components essentially. So if you're doing service mesh, or if you're introducing things like Kafka or whatever, it doesn't really matter what you're bringing there. If you run into issues with ARO, you can actively or even proactively open up tickets with Microsoft and Red Hat, and we'll troubleshoot those components. Whereas like maybe if you're using like a vanilla Kubernetes offering, and I say vanilla Kubernetes offering because in general, like something like, for example, EKS or AKS is really just Kubernetes. It's not the components that are running on top of or alongside Kubernetes. If you open up a ticket for that, in general, you're not going to get the support that you would get with ARO. So for example, if you're having a problem running a Helm chart, you could open up a ticket with Red Hat or Microsoft or ARO, and we'll actually troubleshoot that with you and help you get that running. Versus like if you were using maybe some other service offering, you wouldn't actually get that white glove level of service. And that's a big difference when it comes to the day two and on, or when you're starting to look at mixed clusters running in multiple different cloud service providers or having a consistent experience. That's where we really differentiate ourselves from having a prescriptive offering versus a generic offering in a sense.
Very good. Thanks, Nick. Okay, so the next section I'm going to move into is more Red Hat OpenShift concepts. We're going to talk a little bit about some of the differentiators that OpenShift, different ways you can operate in an OpenShift environment. And just kind of go through those at a high level. This is probably a little bit more for those who, this may be a little bit new or they're learning more about Kubernetes and OpenShift. So this is the way to approach it. And we have this built into one of our examples. So this is deploying with sourced image or STI. And really this is differentiates between, this is kind of where we're getting into kind of an automatic deployment or deployment that's driven by, event-driven changes to our source code. And what it does is it actually we would build our app from changes to the Git repository. And we have an example of this in one of our labs. So a change is committed to our Git repository, to our master branch. Automatically, if we properly hook into our Git repository, with a webhook, it will actually automatically build our image. So it'll go source to image, build the image, and put it into the image repository, and then automatically deploy it, all right? Or this could be deployed by kicking off by an application developer, or it can have some automatic deployment capabilities, and we'll demonstrate that. As opposed to, you can deploy from Docker images, but there's a little bit more manual steps here, right? We have existing image process, would build our application image, we would push that to an image registry, and then we would do some, and I say a manual deployment, we would kick off a deployment to OpenShift to pull that image and put it into an application container. And this may go more towards the angle of I have my own image registry that's outside of Red Hat, but the key to this, and I think both Ross and Nick hit on this one, or Nicholas hit on this one, was the advantage is you have now a platform that can integrate with all those other services, right? Specifically in Azure, where I might have a database running, a Microsoft SQL database. I might have Cosmos DB running. I might have other elements. OpenShift gives you that capability to kind of directly integrate with those other technologies so that you can use it as a complete solution. All right. So, but we will demonstrate the source to image in our exercise, in our workshop, in our labs. Okay. At the highest level, getting into Kubernetes more generally is containers are wrapped in pods, which are units of deployment and management. So a pod is the lowest level or the smallest unit of deployment you can have in Kubernetes. And pods can have single containers or multiple containers. And how we do this is we actually deploy our application into a pod by using a spec, right? So we have a deployment, and we define that in a configuration on how much CPU I should have, how much memory should be allocated, any persistent volumes. And then also how many images should exist, replica sets, those things can be set up within the configuration, right? The second concept is services, right? So services, it's basically a grouping of pods that are running on the cluster. And we do this based upon selectors, labels. So services provide standardization across the cluster. They can also provide some load balancing capabilities. And then they also facilitate discovery so that we can have these kind of zero downtime applications, right? But the key here is they're signed with an IP address, but when they can access, I'm sorry, let me back up. So they can access, they're assigned an IP address and a port pair. Okay, so we have backing pods that this can provide kind of a proxy to our backing pod, right? I don't know if I just explained that correctly, but services provide a grouping of pods that can be accessed through the selector of this label, right? And I think it becomes a little bit more relevant as we move forward. Okay. And then we can also have, obviously, different labels so that services assigned IP address, so that we can arbitrarily add pods in the back end. So Derek, you want to jump in and maybe take a little bit more? I don't think I explained this maybe as clearly as possible.
I mean, sure, yeah. So to your point, the way that the smallest unit of measurement is pods, you can have multiple containers inside of the same pod. The only reason you would ever do that is if you have an instance where you need two containers to always live on the same physical host at all times. An example of this would be like if you have a database and you're like MySQL and you're trying to run a database web interface for managing it, and they have to always operate on localhost, then you would put those two containers, one for each process, inside of the same pod. After they're deployed, whatever pods you have, you get a service selector, and that service selector essentially acts as a load balancer for your different pod sets that you have out there. That then can have an expose point where you say, I want to expose this route to anything external to the cluster, or it could be unexposed to the internet and only be routable inside of the cluster. The way that pods are able to intercommunicate with each other is anytime a deployment is put into a different project space or work group, they're going to talk to the internal IP address of that service selector so they can be load balanced to the individual pod underneath. They're never going to talk directly pod to pod. That's just not the way that you would design something inside of a Kubernetes or OpenShift environment. Specifically, you would always use a service selector. Now, depending on the type of software-defined network that you're using, whether it be multi-tenancy or a flat network, you could also have it set up so that only certain project spaces from a policy perspective are able to talk to each other, meaning that certain VIP spaces, certain VLAN spaces for the selectors are only accessible to certain projects and not to others. This is how you start to separate out roles and operations of who can do what from a security perspective to ensure that, hey, if I have a project over here that has nothing to do with a database over here, those two things should not be able to network talk to each other. That's, I assume, all that you would want to talk about in this point, Tim, unless there's more you would want me to touch on.
No,
So Derek, the question is here, if you have like two VIPs defined, so one for application, one for like database. So you define two different VIPs to differentiate the services. So this is what answers it, right?
Yeah. So in OpenShift, whenever you deploy an application, right, and an application essentially is defined as a containerized service. So that could be a JBoss instance. It could be a Tomcat instance. It could be a database instance, whatever that may be. You're going to have one or more pods that represent that instance. And then you're going to have a service that acts as a VIP, if you will, for that service backend. So your application that would be, let's say, your front-end app server, JBoss or Tomcat, that's going to have its own series of pod and its own service front end. And the database is going to have its own series of pods and its own service front end. And those application pods are going to route to that service,
right,
VIP, if you will, that service load balancer, to be able to talk to the pods underneath it. Does that make sense?
That makes sense, yeah. So to differentiate, you have to have two different VIPs like one for apps, one for database.
Oh, yeah. So when I'm talking about VIPs, I'm talking about hypothetical VIPs, right? So when you create an OpenShift cluster, you're going to give it a certain IP space for it to be able to auto aggregate sources from. I'm not talking about VIPs in regards to, say, like an F5 load balancer, because OpenShift has its own internal router and its own internal virtual network that it's going to manage on your behalf.
Exactly. Yeah.
Okay, so just making sure we're all on the same page. So yeah, you're going to get, for every service endpoint gets its own private IP address that it's only addressable by policy to what you want it to be addressable to. Out of the box natively, every project will be able to talk to each other unless you otherwise state it shouldn't from a networking perspective. But at the point at which these projects are deployed and you've locked things down, each service endpoint will have its own private IP address, which you would have a front-end app talk to that service's IP address in order to talk to the back-end database that it represents. If you wanted to expose it to the internet, you could say OpenShift expose this route, and you'll have a separate IP pool that's for external-facing IP addresses, which then get routed through the OpenShift router. And the OpenShift router is an instance of HA proxy, which you usually put behind something like an F5 load balancer or something like that to represent it from a DNS perspective, because that router essentially is a reverse proxy, which goes, anytime I see a DNS entry, let's just say it's app1.example.com, and that gets routed to the OpenShift router, it's going to know to reverse proxy that to the right service endpoint in the backend inside of OpenShift. Does that make sense?
That makes sense, but once I'm exposing the router, once I have configured my router pod, and if I have to expose it externally, where I have do I have to have the external certs configured over the router pod, or what I have to do on the router pod to expose it to the outside world?
Yeah, so you don't have to do anything other than run a command for expose. Well, it depends on what we're talking about. There's two different ways to expose a service.
They're exposing the service to outside world, like the whole this container or any application is deployed on the container or the pod, and I want to expose that to the outside world.
Yeah, so if you want to expose it to the outside world, the easiest way to do that is through a regular expose command, which what it'll do is it'll create a DNS entry that the router recognizes inside of OpenShift, as you're seeing on the screen right now. Say appprod.conso.com, right? That route now recognizes any traffic that hits the router that's looking for this DNS entry is going to get reverse proxied to the service endpoint that represents those pods.
Okay.
You don't have to do anything for that. So as long as you have, let's just say a wildcard DNS entry for contazo.com, that points to that route from, say, your F5.
Right.
In the event you wanted to manually enumerate, I want to have every individual DNS entry routed into internally, you'd either A, have to create that DNS entry inside of your F5 or your load balancer, whatever it is, manually to route to that router, or you'd have to use a built-in integration. There is one for F5, I believe, don't correct me if I'm wrong, Red Hat team, Nicholas, you might know this, if there's one for Nginx as well, but I don't remember if that was ever published or not. I know at one point there was one in demo state. But the F5 one has long since existed. So if most people use an F5 big IP, you can use the integration there and it can auto-generate DNS entries for your VIP for you. If you set that up. That's a lot more complicated. Most people don't do that. Most people just use the wildcard VIP for internal traffic.
We do wildcard VIP only. Yeah, we do wildcard VIP. So anything like if you say, let's take contaso.com. So if I put like my name, like Derek or vikas.contaso.com, it will hit the VIP and it will go. But the exposing, the question was. Okay, thank you, Derek. Yep.
No problem. No problem. Tim, you good?
Yeah, good. Thank you, Derek. Appreciate it.
Yep.
Awesome. And we already kind of rolled right into our next slide, which is routes expose to services and load balancer to provide readable URLs for the app. So this is the way you're going to get access from an application talking through a URL, correct? Or talking to a DNS entry as opposed to having IP addresses exposed. Okay. And routes are also important because when you're getting into an environment where you have to split traffic between multiple services, maybe you're doing canary deployments and you want to be able to split your traffic, like a traditional application WAP, or you would set up testing to where I want 90% of my traffic to go to service A, which may be my production traffic, And then I want 10% of traffic to go to my new service, my service B. I'm releasing this in kind of a rolling canary deployment. And then I want to be able to adjust that balance over time so that eventually my service B becomes my production. And then as I come through my next process, I would have service C, that I would do the same process. So you can split traffic between multiple services because I want to control the amount of service requests or users going to one service as opposed to another. Okay. So that kind of comes to the end of our concepts. So I want to stop there just quickly. I know we've had some good interaction. Are there any questions about what we've covered so far from a conceptual perspective or OpenShift or ARO just in general before we get into the lab?